Hello friends, look at this beautiful exercise we have here. Let's solve it. We need to find the shaded area of the figure. We know the radius of this sixth of a circle because here are 60 degrees, it's 10 centimeters. And so this angle is 60 degrees and we have a circle inside it. Now let's erase the shaded area for a moment and we'll bring it back at the end. Very good. Now what we are going to do is draw a line dividing this, a sixth of a circle, in two equal parts. How are we going to divide this part here? So the circle will also be divided into two equal parts. Let's do it. We draw the line and it must pass through the center of the circle because it is a circle inscribed within a sixth of a circle. Very well. Now assuming that the center of the circle is roughly over here, let's draw a line from this point of tangency between the circle and this part of the room. From the sixth of the circle up to the center, we're gonna draw that line. So we draw this line and we'll do the same from here. We draw a line from here to there. Okay, now we are going to erase the 60 degrees. We already know it divided in two equal parts. Therefore, this here is going to be 30 degrees, yes, of course, and this here 30 degrees. Fantastic. Over here we have two perpendicular lines. This chord and this line we just made are perpendicular, so there are 90 degrees here. If there are 30 here and 90 here, this must be 60 degrees. Now here we will also have 90 degrees. And notice that this line, which is the circle's radius, it's reaching a point of tangency with this line. So there are 90 degrees in this entire angle, and if this small angle is 60 degrees to reach 90, then this has to be 30 degrees. 30 degrees, fantastic around here. If we have 90 and 30, this has to be 60 degrees. Very good. The same thing happens up here. Not for the moment, we're just going to leave it at there are 90 degrees because it's the radius with a tangential line. So we're going to call the radius r, yes, and we're going to put here goes, and I'm going to remove this from here. I'll put it here and we're going to call this line here r as well. That we had 30 degrees. Now pay close attention to this triangle that I'm highlighting here. Over here we have 30 degrees and 90, which means this angle is 60 degrees. Let's draw this graph of this triangle here. We'll rotate it and draw it over here. Look, it's going to turn out this way. We'll stay around here. This angle will end up right here. Over here 60 degrees. Up there we'll have 30 degrees. Very good. And here we have the 90 degrees. Now this, which is r, the radius, is the side that connects the 60 degrees to the 90 degrees, meaning this part here is r, right? And what do you say if we draw another line and draw another triangle just like this one here? Notice, we are going to do it. We draw this here, another triangle just like it, don't we? Here too you'll see 30 degrees. Here you'll see 60 degrees. And here 90. And this will also be r. Alright, now take a look, because this here is also the circle's radius, it's also r, and all this right here is the radius of the sixth of circles and of this whole figure, because this is 10, then from here to here will also be 10, and from here, from the center of the circle up to here is going to be 10 minus this part, meaning this is 10 minus being. And this part here is the hypotenuse of the triangle we had drawn here. That is, it's the side that connects the 30 degrees with the 60 degrees. 30 with 60, so this is going to be 10 minus r. So since this triangle is equal, then this will also be 10 minus 0. Now tell me that this triangle isn't an equilateral triangle. The whole triangle, here I have 60 degrees, and if we add 30 and 30, here I have 60 and here 60. So it's an equilateral triangle, all its sides must be equal. Over here I have r and r, so this whole side has to be 2r. Therefore this side, which is 10 minus r, has to be equal to twice r. We're going to put that here. And 2r must equal 10 minus r. We move the r to the other side and we get 2r plus r equals 10. We have over here 3r equals 10. And finally, we can say that the radius is 10/3 of a centimeter. We won't put the units at the end. We're going to make it fabulous, right? We have already found we have the radius of our circuit already. The next step will be to find the sides. Notice this triangle that I'm highlighting here. We had said that here we have 30 degrees, here 90 degrees, and here it has to be 60 degrees. And since this is 60 and it has to be 90, 30 and all, this must be 30 degrees. Plus there are 90 degrees here and 60, so this has to be 30, right? Let's pay close attention to this triangle. And with the same premise as a moment ago, we are going to find one of its sides. Pay attention. I'm going to draw it over here. Let's draw it over here. This triangle of 60 degrees over here, 30 degrees over there, and here. 90 degrees, and so this here that connects the 30 with the 60 is R. So this will be R, very well. And what if we draw another triangle towards the other side? Another equal triangle, not 60 degrees and 30 degrees here. So what's up? Which means this here will also be R, and this part over here is going to be R2. So as we have half from here to here, this must be R halves. Alright, we've found this part of the triangle. Take a look. This part over here is kinda... Now we're going to find the height. How? Using Pythagoras, because it's a right triangle and we have two of its sides. So we're going to use Pythagoras. Pythagoras tells us that to find one side, side A let's say, is equal to the square root of the squared hypotenuse minus the squared side B. Side A will be this side here, this side over here that I'm highlighting. Yes, so A will be equal to the square root of the squared hypotenuse, where the hypotenuse is R. So it leaves me R squared minus side B, which is this part here that we already found to be R to the half. So we are left with R times all this squared. We have that equals the square root of R squared minus R squared is R squared and 2 squared is 4. Very good. Now let's add these fractions from this fraction and this whole number, shall we? 4 times R squared gives us 4R squared minus R squared is 3R squared over 4. Phenomenal. Now we can distribute the root up and down, and taking out the root, we'll find that A equals the square root of R squared is R. Then the square root of 3, there's no exact square root, so we'll leave it written like this. The square root of 4 is 2. Remember that all of this is under the root and everything is inside the root. Very well, we have it here, which is fantastic. With this, we can now find the shaded area. Let's see how we do it. First, we'll erase this part here and only leave the data we're interested in. And that's of the even actually from here. So I erase, right? Very good. Then let's jot down this data over here. R equals 10/3 and equals or times the square root of 3 over... Alright, let's delete that then. And now, if we're going to find the shaded area, remember that the shaded area was this little part here, right? Let's put it for a moment. So this piece right here is 120 degrees, right? Am I right or not? Is 120 degrees. So this here is a third, to say it's a third of this circle we have written here. Then the shaded area is going to be equal to the area of a third of a circle. So we're going to describe it this way. Minus what? Minus the area of this triangle here minus the area of the triangles. So we have that. The shaded area is going to be equal. We're going to move it a bit up here to have space. The shaded area will be equal to the area of 1/3 of a circle. 1/3 of the circle is picon. By radius squared over 3 minus the area of a triangle is base times height over 2. Very well. Now we have that the shaded area will be equal to pi thirds, multiplied by the radius squared. And what is the radius? The radius we found is 10 thirds, so it remains 10 thirds squared. Less in the the base, what's the base of the triangle? It's this part right here, which is r divided by 2, so r over 2, multiplied by the height, which is how much of that height from here, which was is r, square root of 3, all of this over 2. But here is a little issue. Pay attention that the area of the triangle is not just this triangle here. The triangle here and the triangle down there are the same, right? So we need to write the area of the triangle twice here. Angle over here, so it goes twice in the area of 3. Triangle, which means this 2 simplifies with this 2. And only the multiplication of the base with the height remains. So over here, this 1/2. We would only have left the base, which is this, and the height, which is this. I hope they forgive me. I didn't realize at this moment, but it remains like this. So the shaded area will be equal to P. And thirds, and 10 squared is 100. And 3 squared is 90. Very good. Except for here what remains, we have r by r, which is r squared. Multiplied by, notice, square root of 3 over 2 times 2, which gives me 4. Very good. Now that we have that, the shaded area will be equal to 100 pi and 3 times 9, which is 27 100 pi. About 27. Less. Around here we have the square of the radius, which is the radius we already know. Extension 10 thirds, all of this squared by the square root of 3 and over 4. And this 10 thirds, then squared. We had already done it. Look here, we have, it's 109ths. Let's remove it and put the 109ths instead. 109ths. Alright, can we simplify? Absolutely. The fourth root of 1 and the fourth root of 100 is 25. Awesome. And ladies and gentlemen, the shaded area will be 100 pi over 27 minus 25 square root of 3, about new ones. And all of this, ladies and gentlemen, must be in square centimeters, because we were talking about centimeters, square centimeters. Phenomenal. We've already found the solution to our exercise. This one here is the exact solution, but I'll also leave you with the approximate solution. The shaded area is, it's roughly 6.82 centimeters, square centimeters. Phenomenal, fantastic. Let me know in the comments if you liked the video, and don't forget to subscribe and hit like so you don't miss the next challenge. We'll see each other another time. Bye bye. Bye.